Designing lock granularity. In the world of RDBMSs, we have a little something known as concurrency, and that is we have lots of people and processes accessing our data simultaneously, and sometimes those people and processes attempt to access the same piece of data at the same time. Relational database management systems like SQL Server employ a locking mechanism to ensure that our data stays consistent and the integrity is maintained. Now, in the world of 70-464, there are two objectives that deal with concurrency. The first one you're looking at right now, lock granularity. The second one is how to design for concurrency. Later on in the course, we'll look at that. There is a little crossover between these two, so what I'm going to do is in this nugget, we're just solely going to focus on locking. What is it? What are the internals? And how do we deal with blocks and deadlocks? Later down the road, then, we'll look at concurrency. We'll take a step back and see how to design for concurrency in our data access layer in dealing with things like isolation levels. So we'll kick this nugget off by defining what locking is, what lock granularity is, what blocks and deadlocks are all about. We'll get some visuals and analogies going and just generally have a good time. Then we will head into the internals, talk about lock modes, lock compatibility, lock escalation, and from there we should have a pretty good idea of what locking is all about so we can talk about some common scenarios that lead to locking problems, such as blocks, and some guidelines for designing around blocks and deadlocks. And locking is one of those things that's usually an afterthought. You don't think about it until months down the road when data has piled up, users have piled up, processes have piled up, all these things are hitting your database, and now people are complaining about slow, unresponsive applications. There's chaos in the database with locks, blocks, and deadlocks occurring everywhere. And now you're in firefighting mode. You're chasing your tail, wondering why this is happening, and looking for ways to circumvent it. So understanding how locking works and how to design around it will put it in the forefront of your mind the next time you design your data access layer. And sometimes these things are out of your control. Anybody ever deal with a third-party application? You're responsible for the database and these things start happening? Yeah. Hello, I'm raising my hand many times, and it's not fun. So it helps here to become a troubleshooting wizard in the world of locking because you can really circumvent these issues when they happen and then try to design around it at the database level. So once we get all the whiteboards out of the way here, we'll head into the virtual Nugget Lab. We'll take a locking demo so we can see some of the different ways to lock data and objects. We'll look at blocks and deadlocks. We'll simulate some of those scenarios. And then I'll show you many ways here to troubleshoot. We've got a lot of really nice ways to troubleshoot here. I'll definitely show you DMVs. I'll show you the activity monitor. And I'll talk about profiler, extended events, and even perfmon, the performance monitor. All great ways to troubleshoot locking issues. Let's get to it here and start with locks, blocks, and deadlocks. Oh my. So locking just simply synchronizes access by multiple users to the data within our database. To give you a real SQL Server example here, let's say that user A writes an update that updates three records, 107, 108, and 109. While that update is going on, user B comes in and says, hey, I want to update record 108. Now, if there is no locking in place, what would happen? Who knows? One thing that we definitely wouldn't have is data integrity, and some conflict of some sort would definitely happen. And it's kind of analogous to a bank without a line. Say there's one bank teller, 5 customers walk into a bank, there's no line, so they all walk up to the teller at the same time and start demanding things. What would happen? Chaos. The teller would probably get very confused and give the wrong something to somebody, or probably just quit and walk out the door, which is kind of probably the same thing SQL Server would do. It would say, nope, sorry, no data for you, and it would throw its hands up in the air. So that's why we need locking. And lock granularity just defines at what level is SQL Server going to lock the data. Is it going to lock a range of data? Is it going to lock a single piece of data? Or is it going to lock the entire table? Now, a couple of things that could crop up that are just inherent with locking mechanisms are a little something known as blocks and deadlocks. And these are what can really cause users big headaches and long wait times and DBA's headaches. So blocks and deadlocks are the things that we want to avoid and the reason we're going to properly design our lock granularity. And let me give you another real world analogy to describe these two. So this is kind of funny, and it goes to show what a dork I am, but we were at the toy store not long ago, and this is my little guy here, my littlest guy, and he grabbed this football, and he would not let go of this thing. He was walking around the whole store with it, and I kept saying, hey, buddy, give me the ball. I want to throw it to you. And he looked at me and spoke two of the very few words he knows, and he said, And I said, come on, I want to throw it to you. Give me the ball. And he said, And I said, oh, man. And I just thought to myself, he's blocking my request to that resource. And so I thought it'd be a great analogy here. So that is blocking in a nutshell, really. And if you apply this to the world of SQL Server, then let's say that somebody wrote a big honking query that accesses this entire table, and it's locked. While that table has a lock on it, anybody else that requests access is going to get queued up. They're going to be blocked on that resource until that lock is released. Now, deadlocks are also a very, very bad thing. Deadlocks are bad because there's no good way to get out of a deadlock. In fact, here's a real world analogy. Let's say that big brother has a ball that little brother wants, but little brother isn't willing to give up his ball. Big brother wants little brother's ball, but isn't willing to give up his. So we have two things that both want each other's resource, but aren't willing to give up their own. That's a deadlock. And in the real world, this is where mom and dad would have to step in and employ some epic parenting techniques to hopefully resolve the situation peacefully. SQL Server isn't that nice. SQL Server chooses a deadlock victim and terminates the process. So yeah, I would definitely not want SQL Server as my parental figure. All right, so these are the two things we absolutely want to avoid, blocks and deadlocks, and they can be avoided with proper database design and understanding how locking works. Let's head a little deeper into locking and talk about modes, compatibility, and escalation. Oh, let's start with the resources that can be locked. Forgot about that. So resources that can be locked, we talked about here. We've got the single row, which is the lowest level of granularity there, locking a row for read-or-write access. Key, which is locking a range of data. A page, data or index page. A whole table, that's really what we want to avoid here. And then also a database file. And there are some more in between there. There's an extent and some other things here. But these are going to be the big ones. Lock modes, the type of lock that can be placed on one of these resources. And really it comes down to the two main ones. There's read locks and there's write locks. Your read lock is right here, your shared lock. So anything that's locked with a shared lock are available for select. And this is where we're going to get into lock compatibility, because if there's already a shared lock on a record, that's okay. Somebody else can come along and read that record as well. And somebody else can come along and read that record. So shared locks are read-only locks. You can read records that have a shared lock on them, but you cannot modify records that have a shared lock on them. The write lock is the exclusive lock. This is the lock that is used for operations that modify data. So your inserts, your updates, and deletes. Anything that has an exclusive lock on it is pretty much incompatible with any other type of lock. So as long as there's an exclusive lock on anything and somebody tries to access that record or range of records or table or whatnot, then they will be blocked and waiting until that exclusive lock is released. There's some special locks I threw on here as well, like the update lock. This is placed on a page before an update happens. So what happens here is when the actual update is going to occur on the data page, this lock will get escalated, hence the lock escalation, to an exclusive lock. There's also intent locks. Intent locks are really there to establish a locking hierarchy. And it's there for SQL Server to do conflict resolution much faster. Because if you have, say, an exclusive lock on a row, well, what SQL Server will do is go up the hierarchy, and it will put an intent lock at, say, the table. So anytime anything else is looking to lock, it'll see that there's intent lock, and it won't have to go and scan all the rows because it'll know there's already an exclusive lock somewhere inside of that table. So it's just really there as a kind of a performance boost for, again, conflict checking. Now, this is not a complete list of lock modes. This is a complete list. So the big ones, again, are going to be shared, your read locks, exclusive, your write locks, and then update, and then all of your intent locks. Those are going to be the big ones. There's also schema locks. Schema locks are for objects. You know, you're modifying a table. Nobody else is going to be able to modify that table while you're modifying that table. So that's really what schema locks are all about. And then there's all kinds of different intent levels of locking. There's a bulk update lock, so you can't do anything while a bulk update or a bulk load is occurring on a table. And then there's all kinds of different variations for range locking. But again, the big ones that you're really going to see on an everyday basis inside of a database is going to be your shareds, your exclusives, and your intents. And most of the rest of these anyway are just combinations of everything else. Now, compatibility. If you have a resource that has a lock on it, and then another process wants that resource, it may be able to work with the resource depending on the locks. And that's what lock compatibility is all about. And here's some good general guidelines here is that shared locks are compatible with update locks and other shared locks, so themselves and update. Update locks are compatible only with shared locks, and then exclusive locks are not compatible with anything. And here is a chart right from MSDN that shows lock compatibility across all the different lock types. So this is a good reference point if you're developing an application and you have locking in your mind and you want to know what's compatible with what. This is a great chart to refer to. Essentially, it means here if we have a lock on a shared resource and we want to see if we want to put another lock on it, is that lock going to be compatible? N, which means no conflict, so it means yes, it is compatible, is that. And you can see that shared resources are pretty much compatible with almost everything. Just anything that has an X in it, it's not going to be compatible with, and nothing is really compatible with bulk update anyway. So it just goes to show exclusive locks are incompatible with everything. You will be blocked if there's an exclusive lock on something. So in review here, resources are the objects that can be locked. Lock modes are the type of lock. Compatibility is just simply if there's a lock on this resource and another process wants this resource, is its lock going to be compatible with it, or is it going to be blocked and waiting until that resource is available? And then lock escalation. Let me give you a better example of lock escalation. So let's say that we have a table out there with 100 row ID locks on it. Well, SQL Server is going to recognize that and say, hey, I'm going to escalate you to a key range. So it's just a way of taking many small locks and combining them into fewer big locks. And that's less for SQL Server to manage, which means it's going to reduce the system overhead associated with managing these locks. All right, let's move on, talk about some blocking scenarios and some guidelines to follow to reduce blocks and deadlocks. So how do we design for lock granularity and avoid things like this? Nobody wants to get caught in a traffic jam, including SQL Server. So common blocking scenarios are caused usually from inefficient and long-running queries. These are the things you want to avoid. Inefficient meaning improperly indexed, so they're grabbing the entire table, or they're grabbing more data than they should, or rather than doing an index lookup, they're doing an entire table scan, those kind of things. And then those long-running queries that have lots of logic in them, so they're holding their locks on their table while they're doing other things. Those are probably the biggest things that you want to avoid, and they're easy to avoid by properly designing, again, our data access layer and our queries. Queries that were not committed or rolled back. Things like cancellations. You know, if people have a cancel button, they cancel it, and something didn't get rolled back, well, you're going to have a transaction out there that is uncommitted. And it's just going to sit there and maintain its lock, and it's going to require some kind of intervention. So I'll show you a way around that. Orphan sessions, application crashes, when that happens again, you're going to need manual intervention to make that happen. And applications that do not fetch all results in one shot. They like to walk through the data on your server. Those are ones we absolutely want to avoid. So some guidelines to reduce blocking, well, derp. Avoid long-running queries, yeah, obviously, right? Optimize and tune inefficient queries. It's all about indexing. Properly index and make sure that your queries are using those index, and you'll reduce the amount of time that things are hitting your database, which will overall reduce blocking and performance issues as well as other things. So properly index and ensure queries use them is a big one, in my opinion. Avoid user input within transactions. That's got to be an obvious one these days. You know, don't ask users questions when you're in the middle of running a query, because it's going to just sit there and hold its lock until the user answers. So that's going to be a big one. Keep transactions short. That's another good one there. The shorter the transaction, the less time locks are held. Use lock timeout. This is a good one for these right here. These things that could be outside of our control. Well, if we employ lock timeouts, then no matter what happens, then transactions will time out, locks will time out, and then we won't have to worry about blocking and deadlocking as much. And as always, stress test any application that's hitting your database, because these are the types of things that, again, if you don't plan for them, they're going to creep up months down the road when data, users, and processes start piling up on your database. Guidelines to reduce deadlocks. It's pretty easy to reduce deadlocks. Sequential consistency is what we call this. Access objects in the same order. So if you have multiple queries that do things in reverse of one another, then you're just asking for a deadlock scenario to happen inside of your database. Another really good one that you don't see this one talked about or used or in any tips or guidelines out there in the world, but access expensive objects last. Always put these things last inside of anything you do. Queries, stored procedures, functions, whatever you use to hit your database, do the expensive ones last. And by doing that, by analyzing and understanding the hot spots in your database, the hot spots in your queries, and putting them last, it just means that they're going to hold their locks for a smaller percentage of time. And that's a big one. That's a really, really big one when it comes to reducing deadlocks and reducing blocks as well. Also, use locking hints wherever possible. Locking hints give us a way to override the default behavior of SQL Server. So we can actually control what kinds of locks are placed on our objects at the statement level. Also, if possible, use the lowest isolation levels possible. We'll get into isolation levels when we get into designing for concurrency. Well, I think it's about time we head into the virtual Nugget Lab and see how this stuff works. Let's do it. All right, we're VLabbing now. So we're in the virtual Nugget Lab. Let's open up SQL Server Management Studio. I had a pre-launch down here. Added a new project into the solution, 04.locking. And in here we have a locks.sql script. So let's open this up. And this is just showing you statements that create different levels, different granularities of locks. So this first statement here creates a table lock because we're updating every single row in the table. It's just simply update, name of the table, set, column equals value. And what we're simulating here is that this is going to run for 30 seconds, and then it's going to roll it back. Now, let me do this all manually first, and this is a great way to test it out. So if you want to do this on your own, start a transaction, run a DML statement, and then just let it sit out there like we are here. So let's actually switch databases here to NuggetDemoDB, and let's do that. So let's begin a transaction, update course, set description equals derp. All right, so there we go. So it says 224 rows affected. If we were to run a select statement now, it's going to show that it's changed, but it's an uncommitted transaction. So if we roll this back manually and then reselect from our course, there it is. There's the real description back to where it is. So that this is just a way to test out locking. So what we're going to do here to show you how this works is highlight all of this. This will create a table lock. Actually, let's do everything. Why not? Let's do it all in one shot. So we're going to create all three. We're going to create a table level lock, a key lock, a row, and then down to a row level lock because we're using an index here, and then here we're just using a specific row. So if we highlight all this, we'll have 30 seconds before it all gets rolled back, and that'll give me enough time to head over to troubleshooting, and we'll run one of our DMVs to view the locking information. So let's hit execute, head over to troubleshooting, and down here at the bottom, I threw one in so we can see. Oh, we got to switch our database. Oh, I'm running out. I'm running low on time. Hey, look at that. I did it. All right. So let's look at all our locks here. Let me give us some more room to work with. So there's our key lock. See our range? It locked all of the keys. Here's our object lock, and this is where it locked the entire table course. And then there's one more. There should be one more lock in here. Here we go. Here's going to be our row level lock here at the page level. That row spanned many pages apparently, so it locked all the pages associated with that row, where that data row was spread across. But there it is. Cool, huh? There is all of our locking information. And now that 30 seconds has passed, it rolled it all back here. So we should be good. It's still running, though, which kind of scares me a little bit that it's still running. Oh, you know why? Well, it's technically going to be a minute and a half, right? Because it's going to wait 30 seconds, then wait 30 seconds, then wait 30 seconds. So it's one wait in one session. So total time should be a minute and 30 seconds that it waits before rolling all that back. But there you go. So this is a great way to just test it out and view the different types of locks that happen. So when you're designing your queries, design them, run them, open-ended, leave them open, put them in a transaction, but don't commit or roll back, and then look what it does. Look what it does. And we'll look at these troubleshooting areas to see all the ways that you can analyze and see what kind of locks are generated. But this is just a great way to view your lock granularity. All right, let's head back here. Hey, look at that. It stopped right at a minute 30. It's all done. All right, and everything rolled back, so we're good to go. We should, yeah, and it shows it right here. So here I did a select before and then a select after the rollback. So that's why it shows derp, and then it shows null, and then it'll do the same thing for all of our other data sets up here as well. Excellent. Now, the next thing I want to show you here is blocking. Let's simulate a block. And to do this, let's first just head back to troubleshooting here. Let's execute this DMV. All right, just to prove we have no locks, we have a couple of shared database locks out here. See this S? Why? Because we have two queries open, and we're connected to NuggetDemoDB in both of these queries. So that's why we just have a couple of shared locks at the database level. Cool. No other locks. So let's open up our block SQL script. And what we're going to do here to simulate a block is we're going to highlight and execute any code, step, in locks.sql. Anything that has to do with the course, I should probably say. So you know what? Let's just say highlight and execute. I should say code step 1. Code step 1, just so I don't send anybody down the wrong path here. All right, let's switch our database over here to NuggetDemoDB. And then after that, we're going to come back to this session. So we have two sessions, two connections is essentially what we're going to need to make this happen. The first session or first connection, which is right here, we're going to do this manually, by the way, is right up here, is going to create a lock on our course table. So let's do that. All right, so now we have our course table locked because we started a transaction. We submitted an update. So let's see what our locks look like right now. All right, so we've got a lot of key level locks out here because we have an index on there, so it's using that to lock all the data in that table. All right, and now if we head over to our block script, our second connection, and we want to request that resource. Now remember, there's a actually let's go back to troubleshooting here. Let's see what kind of lock was on there. Look at that. We know X locks are bad, right? Exclusive locks are bad. They're write locks. So we shouldn't be able to do anything including read from the course table right now since it has exclusive locks galore all over it. And if we hit execute, look at that. We're waiting. Now, we should have had data back by now because it's not that big of a table. So we're blocked. We're blocked. How do we know that we're blocked? Well, we can do it a couple of ways. Let me just right-click on our instance here, our SQL Nugget Lab instance, and let me show you Activity Monitor. So if we go into Activity Monitor, we expand processes. We can trim down our view here to the Nugget Demo DB database. That's what we're troubleshooting. There's our connections, and look at this right here. Anytime you see anything in a suspended state, that means it's blocked. It's waiting. And you can also scroll over here and see, this is the blocked by column, and you can filter your view there as well. But we can see we're blocked by SPID 53. If we look at SPID 53, we can right-click on it and choose details, and hey, look at that. Look familiar? That is the statement that is currently blocking. So we could head back over to, let's close out of Activity Monitor here, over to our locks, and let's just roll back this transaction that's causing the problem. And now if we head back to our blocks, look at that. There's all the data. So how could we prevent this specific case from happening? Well, if we go analyze our query, we'll know that we're updating the whole stinking table. And who updates the whole stinking table these days, especially during production hours? You know, maybe if you have something like a price to update because taxes went up, you would do it, or maybe you just create a new calculated column or do it off hours. But you know, in this case, that'd be an easy fix, right? Don't update the entire table or commit the transaction or roll back the transaction right after it was done so it wasn't just hanging out there. So that's a good simulation though, because you can see how blocks work. Now, what about deadlocks? Let's try this one. Let me close out of what we have open so we can get some screen space too. We'll leave troubleshooting up, but in fact here, let's just make sure we have no locks out there. Hey, awesome, no locks. We just have a shared lock at the database level because we have a query window open. Now let's open up deadlocks 1 and deadlocks 2. So how this is going to work here is, to simulate a deadlock, we're first going to run this statement, which is going to, again, update our course table, set the description to Derpin, where course ID equals 100. Then if we head over to deadlocks 2, we're going to update this. The second connection is going to update the nugget table. 3 is this connection, once the first connection's course table. It's going to update that same exact record. And while that's happening, connection 1 is going to want connections 2's nugget table. So we have just the exact same statements reversed. All right, so let's do this. Let's first start with our transact SQL number 1 here. And what this is going to do is should create, because it hasn't committed yet, an intent exclusive lock against our course table. Let's head over to troubleshooting. Let's highlight everything here again, and let's hit execute. And if we look here, object, course, this type is a user or system object, but here's the request mode. So we have an IX, we have an intent exclusive lock at the object level, and then we have an exclusive lock down here at the key level. So far so good. Let's head over to connection 2, and let's run our query here in connection 2, which is going to update the nugget table and do the same thing. All right, so that updated 20 rows. If we head back here to troubleshooting, and we re-execute this query, look at all the locks. All right, so we've got lots of locks here. And the big ones are going to be, we have a lock on the nugget table, that's an intent exclusive, and a lock on the course table, that's an intent exclusive. And then down at the key level, we have a lot of exclusive locks on the data itself. And then at the page level, we also have IX locks. So you can see how it's creating this hierarchy. Because now if any other request comes in, it can start at the top of the hierarchy to do conflict resolution, which will save, again, on some system resources there. So we have query number 1 in deadlock 1, query number 2 in deadlock 2. Now, query number 3 is going to say, in connection 2 here, we want query number 1's resources. And this is going to create a block. So if we execute this, it's just going to sit there and wait because it's blocked since connection 1 already has that resource. Now, here's what's going to create the deadlock, because now connection 2 wants connection 1 wants connection two's resource, which already wants connection 1 resource. So we're going to have the infinite loop scenario going on here. Let's hit execute, and now we're in trouble. And what's going to happen? SQL Server is going to step in and choose a deadlock victim. There it is. so it chose SPID 53 as the deadlock victim, and that was crushed, and we no longer have a deadlock on the system. And you can see that's actually the SPID that we're in here, 53 on our query window. So if we did a rollback here, it's going to say, sorry, there's no begin transaction, because this was the one that was the victim. But if we head over to 57, it says one row affected, meaning this one is the one that succeeded. So if we roll back here, it should work. Hey, look at that. There it is, rolled back. So everything's in the same state that we originally started here by rolling everything back. So that's locks, blocks, and deadlocks. And you can tell we've been relying heavily on our troubleshooting script here, which wraps a very, very useful DMV called DM_tran_locks, which gives you all the information you could ever want to know about locking. And I just left join that to the object so we can get the actual name, and you can see that. But you can mix this with a couple of other ones. In fact, let me scroll up here. I listed them all inside of the script. Exec requests, waiting tasks for discovering blocks, and tran locks. Those are the ones that you can all combine together and really get some powerful information about the locking that's going on in your database. And I just threw a couple of these together. But activity monitor you saw, DMVs, here's one that uses exec requests to identify blocking sessions. Pretty much the same exact information you saw on activity monitor. So if you didn't want to use activity monitor, a lot of times I love having a library of scripts handy. That way you can just pop them in a script and run it. A lot easier than waiting for activity monitor to do its thing. But what's nice about activity monitor is you can just use your mouse and you can right click on anything you want and kill the process if you need to. You have all that nice built-in filtering and that control inside of the activity monitor. So whatever floats your boat, when it comes to troubleshooting, use it. Here's another one that combines OS waiting tasks, exec sessions, exec requests. And this is also a nice one if you want to extract the SQL. You can do the text out of it. That'll actually give you the last statement that was ran so you can see what SQL statement is causing the problem. And then down here, I also wanted to show you, actually, let me scroll back up top here. I wanted to show you some statements. So if you want to test this stuff out on your own, then along with the select and insert and update and delete statement, we can use table hints. And that means anytime after you specify a table in your query, if you do a with and then into parentheses use a hint, a locking hint such as this, you can force what lock SQL Server will use for that query. And to give an example, I have one down here towards the bottom where I created a transaction, did a select star from course with tab lock, X lock. This will create an exclusive table lock on the course. And you can see this by doing just that. Let's just highlight everything, start a transaction, do it, and let's run our DMV here. And look at that. Now we have an exclusive lock on our course table. Cool, right? Cool. Now you can do the same thing here with page lock. And by the way, if you didn't want to do tab lock space X lock, you can also do tab lock X. It's the same thing. But you can do an X lock combined with a page lock or row lock or whatever to make it an exclusive lock. But let me just do one more here. Let me do both of these so you can see all of them. Highlight them and check that out. So now we've got page level exclusive locks because we did a with page lock there, so it'll lock the pages that data sits on. Here's our course lock, and then here's our intent lock above the page level lock, so SQL Server can efficiently do its conflict checking. Now the last thing I want to go over here is just taking you through all these tools because you're going to use these in conjunction with one another depending on your situation. Activity Monitor, again, your SQL Server Management Studio way of doing things. You have a nice GUI to work with, as we saw. Dynamic Management Views, these are the three big ones you'll use for working with locking information. Your T-SQL way of doing things. Both of these are going to require view server state permission in order to work with. SQL Server Profiler and the Extended Events Profiler. I love these tools. These are great. These are great for discovering hotspots in applications, either your own application or when you're developing an application or even when you're supporting third-party applications. It's a great way to find out what parts of the application are causing the problem. So it's your real-time window into what's hitting your SQL Server. So and it's one of those things too, if you want to set up a trace to run for a while, you can do that so you can trap all the information. And if you want to trap anything lock related, look in the locks event category, all kinds of data points to work with locking information. And then we also have Performance Monitor, the Reliability and Performance Monitor. Look for the SQL Server locks object. This is a great way to discover trends. So if you want to find what parts of the day these hotspots are occurring. You can set up a performance monitor and see exactly when the chart starts spiking all over the place and discover those hotspots throughout the day. So all excellent troubleshooting tools that you'll use depending on your situation. In the CBT Nugget, we learned how to design for lock granularity. We started off by defining locks, blocks, and deadlocks. We saw locking resources, lock modes, lock compatibility, lock escalation, and then we saw how to properly design for lock granularity, which is really all going to be around the types of queries that are hitting your database. We want to make sure that they're utilizing indexes, that they're short, and that they're optimized. We then jumped into the Virtual Nugget Lab. We saw how to run queries that create locks, how to troubleshoot them, how to view locking information, what blocks and deadlocks look like, and many of the tools that we can use to troubleshoot locking in SQL Server. I hope this has been informative for you, and I'd like to thank you for viewing.